Hello! In this example we will see behavior of the powerful generator during a closed phase B to ground short circuit in the grid. Here we have currents, fault was cleared from the system in around 70 milliseconds. We see voltage decrease in phase B and C because the step-up transformer has delta winding connection on the generator side. So first of all, I want to remind you that we have a custom calculation channel and all power calculation can be done by using this option. But in case of a three-phase apparent power calculation process will not be too quick, so to make the process easier, we've added power channels. So let's calculate power flow in phase B of the generator. I'm selecting the voltage and current of phase B. Then I need to select units. In this case they are kilovolts and kiloamperes. At the bottom here is an active power channel, then reactive, and next to the top apparent power channel. Power channels are not periodic, so you need to look at instantaneous values here. Units are megawatt, megavar and megavolt ampere. You can see oscillations in power. Here is 1 second, so the frequency of this oscillation is around 1 Hz. Let's add three-phase power. The procedure is pretty much the same. Before the fault, the active power was 1008 megawatt. Here was a dip around 854 megawatt. And only here the generator returned to its normal output that was before the fault. More than 3 seconds left. The next example is from a wind farm. We'll look at the behavior of the typical 4.5 megawatt wind turbine during phase A to ground short circuit on 110 kV overhead line. Here we had a trip from the overvoltage protection. I want to see a vector diagram. I'll add phase A voltage and current and select phase A voltage as base channel. Here is one problem. Before the fault, vector diagram shows that power is received from the grid, but this is not correct. I'm sure that the turbine generated power. The idea that made this record doesn't have directional functions, so the commissioning engineer didn't check CT polarity. In this case, it doesn't matter, but for my needs I want to reverse currents and I'll use our custom calculation channel for this. So here the fault was cleared and the wind farm lost connection to the grid. Here the turbine was disconnected from the 35 kV side by overvoltage protection. Let's look at the voltages and digital channels. Here phase B voltage increased to 27.5 kV. I'll add power channels to phase A. Checking units for the voltage, it's kV. The turbine lost synchronism during fault. The time was too long. In this case, the wind farm had only one connection to the grid. Another 110 kV line was disconnected from the grid before, and it happened that the primary protection communication channel was damaged, and we saw backup protection relaying. The last example is the 330 kV transmission line. Maybe you have seen my video about 4 ways to determine the direction of the fault, so this is one more way to do that. Before the fault, this substation received power through this line, but during the fault, power was directed inline. So let's add active and reactive power channels. You can see the same here. Before fault active power is negative, during the fault it's positive, and this means that fault direction is forward in the line. Thank you for watching. Peace for everyone.